Hi, everybody. Today on the Data Show, we're going to talk about data definition and how it relates to data validity. That is going to be our single and most important topic today on the Data Show. 30 minutes, we'll be talking about data. But today, specifically, we're going to talk about data definition. And I think this is the one area where we as data, I guess, people that take in the data, people that take it from either the media or somebody else, sometimes when we talk about this stuff, we need to get to data definitions. Let's go back to just some, I guess, basic definitions, things that have to be defined in order to be understood. In project management, we talk about requirements, and those requirements are part of a definition that we talk about, the definition of done. And this definition of done is so important from a project management point of view, because unless we understand what done means, completed means, we are not at this point at that level to be able to complete the project. And it's interesting how sometimes we get into that definition of done and we get so wrapped up in the requirements and those things that talk about the project itself, we tend to forget what done means. And I think that politicians, and I'm sorry, politicians, but I'm going to pick on you today, is that they never explain what done means. They never explain what completed means. They have this constant deal that they talk about things in the future. Like, for instance, whenever they talk about, we are going to be able to save $1 trillion in our debt, $1 trillion in the debt over a period of 20 years. Wait a minute. Wait a minute. So everyone just thinks, oh, $1 trillion in debt we're going to save over 20 years. And I love the way that they do things. They kick the can down the road. They always sit back and go, we can save this much money by 2026. And we sit back, and I sit back all the time and I say to myself, people are just drinking this Kool-Aid. It's just so funny to watch how this definition of done, definition of completed never gets done. It never gets completed. 2026, and the next thing you know, it's 2042, and next thing you know, it's 2050, and it just goes on and on and on and on. So data definition is extremely important when we talk about data validity, right? I mean, that's the way it goes. So let's talk about this just for a second from a standpoint of climate and climate change. First of all, and I think this is extremely, extremely important, is what is climate? What's climate? So let's just go through and figure out what climate is. So we're just going to go, and okay, yeah, you go to Google, whatever you want. The definition of climate. Okay, so what is the definition of climate? The weather conditions prevailing in an area in general over a long period. Well, what in heaven's name does that mean? What's a long period? What's climate? What is a long period? What does this mean? So, let's take a look at Merriam's dictionary. A region of Earth having an average course or condition of the weather. And this is interesting because a lot of people sit there and say, it's climate, not weather, stupid. Well, guess what? Weather is used in the definition of climate. So, sorry, that's the way it goes. At a place usually over a period of years exhibited by temperature, wind velocity, and precipitation. Again, there's nothing here talking about there's nothing here talking about these areas. So let's talk about climate definition. All about climate. National Geographic Society. Let's talk about that. National Geographic. What is climate? Climate is the long-term pattern of weather in a particular area. Oh my gosh, you got to be kidding me. What does long-term mean? So a region's weather patterns, usually tracked for at least 30 years, are considered its climate. So when we talk about climate change, we talk about change over a period of 30 years. It's got to be tracked for at least 30 years, so minimum 30 years. So, okay, 30 years. So let's just go with 30 years and go from there. So what do we do next? Well, let's talk about temperature, because remember, that was mentioned as part of climate. So what is temperature? Well, temperature, again, you got to define that. What does temperature mean? Well, temperature could mean like this: the average annual temperature. This is weather.gov. This is average annual temperature by year, over from 1875 all the way through to 2022, with an average annual temperature of 52.2, right? So all these areas, right? Average. This is in the United States, by the way. So all these are from 1875. Now we have to sit back and we go, okay, was the definition of temperature the same in 1875 as it is today? Was the average annual temperature in 1875 the same that it is today over the United States? Well, let's take a look at this for a second. First of all, in 1875, did we have all 50 states? No, in 1875, we definitely did not have Alaska or Hawaii. We didn't have those two. So all of a sudden now you sit back and go, what other states did we have? Well, we have to look that up. So, but we know we didn't have Hawaii, and we know we didn't have Alaska. One of the main temperature places they have for sea temperatures and sea level temperatures is in Mauna Loa, which is in Hawaii. So now all of a sudden, all this comes to, you have to ask. So a definition is extremely important whenever you talk about data. And people sit back and they go, well, that can't mean all that much. Okay, well, let's talk about some things. Let's talk about when you talk about COVID deaths, COVID-19 deaths. Okay, so we talk about that. What's the definition of a COVID-19 death? What's the definition of a COVID-19 death? Very, very important. Is that somebody who came in with the clear signs of COVID and died? Is it somebody that came in with with a positive COVID-19 test and died? And if they died, did they die from COVID-19? And that, again, is a very hard definition to come by, because, and I'll give you an example, a very close relative of mine came in and had Legionnaire's disease back in the 1970s. As soon as that they diagnosed it with Legionnaire's disease, and the individual almost died. But at the point that it became pneumonia, the doctors were happy, because it was something that they could, in fact, treat. So they treated the pneumonia. But if that person would have died, would they have died from pneumonia, or would they have died from Legionnaire's disease? So those are the things, those are definitions that are so important. And everybody sits back and goes, well, now you're just being persnickety. No, I'm not. I'm trying to be in the data world what they call as standard. I'm trying to set a standard. So let's keep talking here about climate. So here's global atmospheric concentrations of carbon dioxide over time. Now, this goes back all the way to 800,000 years ago. Now, you've heard me talk about this in the past, about this predicting the past thing. That this is the concentration of carbon dioxide, and the thing is, you notice it's saying global atmospheric concentrations of carbon dioxide. How is that done? How is that done? It's done by it says it right here, from hundreds of thousands of years ago, measured in parts per million. Data came from a variety of historical ice core studies and recent air monitoring sites around the world. Recent air monitoring sites. Recent. What is the definition of recent? It's not 800,000 years. I'm going to tell you that right now. So basically what's happening is they are trying to, put this against this, and they're saying, oh, this was the carbon dioxide concentration, and look how much it's increased just in the past 70 years. Well, Okay. I will still tell you again, and I will tell you again, and I will tell you again and again and again. The recent air monitoring is done from where? Where is the sampling done from? So once we get to that point where we can sit back and say, this is the data definition of climate, this is the data definition of carbon dioxide, and it says in parts per million. Okay, so parts per million, cool. That's what, but it comes from ice core, variety of historical ice core studies. So I sat back and I thought, okay, fine, that's fine. Where are they getting the ice core samples? Not getting it from the United States. I can tell you right now, not getting it from Canada. So they're probably getting it from other places that have basically ice cores most or all of the year. Well, two of the places they're getting it from is Greenland and Antarctica, which have ice most of the year or all of the year. So this situation, you sit back and you go, okay, where are the ice cores being done? So what I did was I just, what is the situation? I put in heat warning here, and the reason I put in heat warning is because, again, it's global warming thing, which of course is not used anymore. It's now climate change, but whatever. So this is what we have here, and CDC even has extreme heat advisories on that stuff. So I thought, well, that's interesting. So ice core studies. So I went into different ice core studies, and I thought, okay, what's going on here? So I went to Scientific America. And it says here that, here it is. Our method takes into account more data and shows that age difference in Antarctic temperatures, CO2 is less than we previously thought. I think this can help change tone discussions about climate change. Well, so basically what's happening is they're even second guessing themselves at this point. But the scientists can study Earth's climate as back as 800,000 years by drilling core samples from deep underneath the ice sheets of Greenland and Antarctica. Okay, where? Where in Greenland? Where in Antarctica? I want to know: are they digging it? Are they taking it from the same area? Are they taking it from others? And also, those are the only two areas you're getting ice core samples from. Interesting. Okay, nothing from the North Pole, nothing from the North area. Are you getting ice samples from that? As far as I know, Scientific American, the only thing they talk about is Greenland and Antarctica. Now, let me compare this. Let me talk about sampling here just for a second, because I think this is important. And I've talked about this before, and I'm sure that many people think it's the most boring thing ever. But what is sampling, right? What is sampling? And when they talk about random sampling, what is random sampling? So random sampling, let me take this off here for a second. Okay, so random sampling is this. Random sampling is the ability to sample and knowing that all events are being considered. When you're random sampling, you are ensuring that when you're random sampling, when you're picking something at random, all events, all objects are equally considered in that random sampling. So this is not random sampling. It's not. It's not. You sit back and you go, so how did they choose Greenland? Did they, how did they random sampling in Greenland? Even that's almost ridiculous. When you go into an ice core, you have to go into an ice core. So that means you're going to Greenland or Antarctica. Okay, well, at least, thank God, there's two sides of the equator that are being taken into consideration. Good, at least we have that. So that's taking into consideration both sides of the world. Yay, that's good. But it's not random, and it might be called systematic sampling, whatever it is. Also, how many samples do you need to make a valid conclusion on that? Now, I saw these samples that are being treated, and let me tell you something. I have to admit, myself as a data guy, that the methodology by which they collect these ice core samples, is absolutely amazing. I mean, they have a very set methodology by which to collect these samples. I mean, it is painstaking. It is painstaking what they do to make sure these samples are clean, that they are not contaminated by anything within the evidence. I mean, it's almost like a chain of evidence type of thing. I mean, it's almost like it's forensics by all. I mean, this is evidence. This is well collected, well preserved evidence. The thing that I am saying is that are those samples from as many, is everything equally considered? Is all Greenland equally considered in those ice core samples? Is all of Antarctica considered in those ice core samples? Don't know. I mean, because I tried to drill down as much as possible. So I'll tell you what, I'm going to assume they are. I'm just going to assume that every sample taken from Greenland or from Antarctica is equally considered, that the whole area is equally considered. Even if that is the case, why not drill in other areas? For instance, I know Siberia would be a good place to go, right? Right now, Russia would tell us to go, pound sand, but basically that would be a good place. Other places in other areas that are ice areas would be nice places to be able to drill. So those are the ice core samplings that are being done, and I'm sure that NASA and National Geographic and the Geophysical Year and all those areas are doing that, and EPA, to be able to make that work. So what I did was I wanted to show you the NASA area and how it works. So NASA, and I'm gonna put this up there. NASA, I mean, they go into ice core sampling and introduction to ice cores, and this was done in 2017, so it's a little dated, but not that dated, right? So it talks about how the sampling is done, and where do the cores come from? Ice sheets and glaciers near the Earth's north and south poles. Okay, so they do get it from there. Formed from years accumulating icefall. Blah, blah. Researchers drill ice cores from deep, sometimes more than a mile or 1.6 kilometers inside the polar ice sheets in Greenland and Antarctica, as well as some high latitude ice caps and mountain glaciers. So yes, that's good. So they're getting it from, again, equator here up in this area. And they're doing it, finding out, hey, this is what we have. What does the ice tell us about past climates? Okay, so they're talking about different climates. Scientists can directly measure the amount of greenhouse gases that were in the atmosphere at the time by sampling the bubbles that are located in these ice cores. So I mean, they do a great job. And here's an ice core right here. I mean, this thing is, it's amazing. I think this is where I found yeah, here it is. These are all the ice cores. I mean, they keep them in containers, and those containers are at climate controlled areas. So I mean, they do try to evidentiary. They do it, from what I can see. I mean, these are a lot of ice core samples. So, but again, what area is it from, right? Where are these things from, and how did they do that? It's the same thing when I showed a while back. I showed the Mauna Loa sea temperatures, and that type of thing. It's from one sampling area. That's fine and dandy, but I don't know how they can sit there and say this is the global climate because of areas within. You see what I'm saying? It doesn't seem to me that we're getting a real, predicting the past type of approach, because you're sitting there saying, oh, 800,000 years ago we had this happen. Yeah, based on some ice cores. Okay, fine, but what really happened? Also, the change in 800,000 years. Did we have the same continental makeup that we have now? Doubtful. 800,000 years, doubtful that was done. Now, this is also based on science, the movement of tectonic plates and all the things that go along with that, and geography of itself, and the fact that even to this day, continents are moving apart from one another. So all these things, come into play with 800,000 years. What did the place look like? And of course, again, that's predicting the past. We have no idea. Look, folks, we have no idea. Here's what I trust. I trust this. I trust this type of data. Although they'll even say, weather.gov and the rest of them will say that before 1901, there were some issues with temperature measuring and that type of thing. So before 1901, there were some issues with that. So even 1875 to 1901, those temperatures are suspect, as to what they do. So then what I did was I did this type of thing, global, and this is really good. EPA.gov has great data aspects. But again, this is all the atmospheric concentrations of methane, concentration of nitrous oxide, halogenated gases, and ozone, and all that from these ice cores. So they're basing a lot on these ice cores, tons and tons on these ice cores. So you can see it's almost seasonal with these ice cores. It's I mean from a year from a millennia point of view. So key points, they give you key points here, which is really good. Water vapor as a greenhouse gas. Water vapor is the most abundant greenhouse gas in the atmosphere. Human activities have only a small direct influence on atmospheric concentration of water vapor, primarily through irrigation, deforestation, so it is not included in this indicator. Water vapor is the most abundant greenhouse gas in the atmosphere. Just, I think that is really important. Is anybody measuring water vapor? How's that water vapor work? So this is interesting. The water vapor is very important. Greenhouse, it allows rain and all that stuff. So this it goes through and tells you different aspects, indicator notes, data sources, measurements come from a variety of monitoring programs, studies published in peer-reviewed literature, global atmospheric concentration data from blah, 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 advanced global, similar figures, satellite, that technical documentation. So all this stuff, it talks about it. You can go to it. It's EPA.gov climate indicators, and you can go from there. So this is what's happening here. I think what the idea behind it is that ice core data. This one from Scientific America. Ice core data helps solve a global warming mystery. Does it? Does it really? Why do some core samples seem to indicate CO2 spikes trailed increases in global temperature? So at one point there were some issues because it was about which come first, the temperature or CO2. Did CO2 come first or temperature, or how did that all work? So they're having some issues with that, and they're trying to reconcile those issues as to what they do. Now, then I turn to tornadoes, because tornadoes, everyone's saying the tornadoes are increasing because of climate change and all these different aspects. And interesting enough, so I wanted to show you, I pulled down some data, and I wanted to show you some of the data aspects on this stuff. So we're just going to go to Excel and take a look at some of this data that I pulled down, and some of this is directly linked to the data that you see here. And thank you, EPA and climate.gov and the rest of those areas that helped me to get a lot of this stuff that I needed to be able to make that work. So I think this is important, and we'll move to this area. So this is tornadoes and fatalities in the United States. And see, I'm going to take this up here. So this is tornadoes and fatalities in the United States from 1950 all the way to 2022. Now, again, climate.gov gives a fantastic look at these types of things. But this is fatalities and tornadoes. This is tornadoes here, the blue, and the fatalities here. Now you can see if I take a look at this and I say, okay, are tornadoes increasing or decreasing based on these yearly tallies as to what they do? So I'm just going to add a quick element here, and I'm just going to add trend line, and we're just going to add a linear trend line. And we're going to go with tornadoes. The tornadoes, according to a linear trend line, they are increasing from 1950 all the way to 2022. They're increasing this much. But again, till 1957, we didn't have any satellites up there, man-made satellites. We had the moon, that was about it. And then all of a sudden, 60s, we had the tracking aspect. So even if I were to get rid of these 5 years here, so even if I were to get rid of them, so instead of doing this, I'm going to get rid of I'm going to get rid of the deals there. And I think that's important whenever we think about this. But if I get rid of these 5 years, would I somehow make that work? Or would it do something to mess up the entire area? So normally what happens is I can do this. It's interesting. It just won't let me do it. Okay, so I'm just going to kill it. So I think it's because it's in another area here. So this is linear tornadoes, goes up. Even if I get rid of these 5 years, it's still going to go up. So tornadoes are increasing. Again, lots more people here, lots of things happening, that type of thing. So let's go to another chart. That's this one, the average annual temperature. Now, average annual temperature, this is what you just saw. And what I did was, again, average temperature is rising. It is rising. But let me show you something here, because I think this is important. I'm going to just go here. And what I'm going to do is I'm going to change it to 0. Because this is what happens when situations like this work. Now look at this. Now tell me what's happening here. I just changed it to 0 rather than to 47 to 52. So how much is the temperature really changing since 1875? How much? I mean, the temperature is not changing all that much, folks. Here's 55 up here. Here's 50 down here. Here's 40, maybe 49, 48. So between 49, 48, and 55, this is what we have. This is called the lie of the display. I can display this so it makes it look like we are in just dire straits. And then I can display it where you take a look at it and say, and again, that comes down to data definition. That comes down to data definition. And that is extremely, extremely important. So, this is some areas I got, some different concentrations of different areas. This is on the Earth's surface here. And again, this is the temperature difference in these areas. So here's 0 to 3 degrees, 0 to 2 degrees. 3 degrees, maybe 3.5 degrees difference. And it actually has come down since that time frame. But is it going up? Yes. The Earth's surface temperatures are going up, according to this data. According to the data. Now, you have to, what's the definition of this data? The definition of this data is it's temperatures measured, observed, basically observed through that area. Now, let me talk about this for just a second, and then I'm going to let you guys go for the day. It goes something like this. Every time a human being touches something, they change it. Every time we study something, we change it. I mean, that's just, and a scientist that says that's not true, then they're not really a scientist. Science, it's very evident. Everything we touch, everything we study, by studying it, we change the environment. We change the environmental standard by which it is. Every time we study a polar bear, every time we study something, we change the environmental factors of that test. So we change it. We change the pattern. I mean, take a look at the people that study polar bears that put up cameras. The polar bear goes right for the camera. They know there's something different in the environment, and they go right for it. They have now changed. That polar bear originally was going to go this path. Now it goes this path. They've changed the individual bear's initiative, going from going this way to going this way because of that camera. They've changed the bear's environmental factor. They've changed the bear's path. That's what happens when we study stuff. Leave it alone. I mean, I get it. It's science. We have to go out. We have to do this data collection, whatever else. But the less intrusive we are, the more that we have the ability to be able to make a clean data collection. And that's part of the deal. So I don't have much time left, but hopefully we covered the following things: sampling and random sampling and how important that is. Also, how to display data, and sometimes the live displaying that data in a certain way. And also, the fact that these ice core samples there's a lot of samples, but they're all from one basic area, whether it be Greenland or Antarctica. Now they say north-south poles, which is good. So hopefully that's enough to be able to gain a perspective as to what's going on. So until next time, check the data. That's what I always say on the data show. Check the data, and please, please, please go out and do some research on this. And you'll find out that data is not what you think it may be, but get a data definition on things that you want to know about. Start that off in a much better way than normal data collection. And to that end, take care. Thank you for watching the Data Show, and we will see you next time.